In this literal equations exercise, what I want you to do is I want you to read the equation and then isolate the indicated variable on one side. So for example, in part A, ax plus by minus c equals to 0, I want you to isolate x on one side. So before we get into that, let's do 3 simple practice. So we have 1 plus 2 minus 3 equals to 0. Still remember how you move these terms to left and right. So we have 1 plus 2 minus 3, right? I move the minus 3 over to the right hand side. That becomes a 0 plus 3. So the equation is still balanced. And then next, I can move the 2 to the other side, equals to 0 plus 3 minus 2. And then I move the 1 to the other side. Then I have nothing on the left, which is a 0. 0 plus 3 minus 2 minus 1. So the equation is still true because 0 is equals to 0. So the next one, so how do you move the 3 to the other side? You multiply both sides by 3. So you have 5 minus 2 equals to 1 times 3. So 1 times 3. And then you add 2 on both sides. 1 times 3 plus 2. And then you subtract 5 on both sides. So 1 times 3 plus 2 minus 5. So that's how you move each term to the other side one by one. And then the next one, how do you isolate 2 on one side? So all you have to do is you divide 7 on both sides. So 2 is equals to 14 divided by 7. So 2 is equals to 2, right? So let's start working on part A. So part A, I would like to solve for x. So the x right here. So first of all, let's move the c and the by to the other side. So first, let's add c on both sides. Ax plus by equals to 0 plus c. So which is equals to c. 0 plus c. That is equals to c. And then you add by on both sides. So we have ax equals to, subtract by minus by. And then you divide both sides by a. So x is equals to c minus by divided by a. So that's how easy it is. And then the next one, you would like to solve for r. So you keep r on one side. That means you have to divide both sides by pt. No, pt. So this is just like, let's say you have 12 equals to 2 times 2 times 3. And you want to isolate these 2 on the right side. So all you have to do is you divide both sides by 2 and then you divide both sides by 3. So 12 divided by 6 is equals to 2. Okay, so let's back to part B. So we have r equals to I divided by over p times t, or divided by p times t. And then in part C, you want to isolate k on one side. Let's do it. So first of all, we would like to multiply both sides by the denominator. So that means you have to multiply both sides by m minus k. So x is equals to n divided by m minus k. So you have to do this. So you multiply both sides by m minus k. This side m minus k. So if you are a little bit confused, so here is what you can think of. So how about this? 14. I just want to use, and I want to do it in another color. How about this? So for example, let's say you have 14 divided by 2 equals to 7. If you multiply 2 on both sides, so multiply 2 on both sides, you have 2 times 7. And then these 2 cancels with these 2. You have 14 equals to 14. Back to this problem. So you have m minus k times x equals to n. And then there is a distribution right here. You have to distribute the x to the k and the m distribution. So let me give you a simple example. So let's say you have 2 times 5 minus 1, what is that equal to? 5 minus 1 is equals to 4. 2 times 4 is equals to 8. Or you distribute to the 2 to the 5 and a 1. So 2 times 5 is equals to 10, and then minus 2 times 1 is equals to 2. So you get 8 anyway. So that is called a distribution. Alright, so you have m times x minus k times x equals to n, and then you want to isolate k on one side. So how about this? You add kx on both sides. So you have mx equals to n plus kx. And then you subtract n on both sides. Mx minus n equals to kx, and then you divide both sides by x. So k is equals to mx minus n divided by x. So that's how you do it. And then the next one, part D. So let's go to part D. We have to solve for a. All right, the a is in the denominator. So first of all, let's add this on both sides. So 1 over r equals to, or not equals to, 1 over r plus 1 over b equals to 1 over a. And then you want the a to be in the numerator. So the only way to do this is you multiply both sides by a. And then you have a distribution right here. So you have to take a times 1 over r and then plus a times 1 over b. So that will be a times 1 over r is a over r, and then plus a times 1 over b, that is a over b, equals to, this a cancels with a, so we have a 1. And then you can factor the a out, so a, factor that out, so that is 1 over r plus 1 over b equals to 1. And then you divide both sides by the stuff inside the parentheses. So that is a equals to 1 divided by 1 over r plus 1 over b. So that is your final answer. Again, this is, you have a fraction inside another fraction, 1 over r and 1 over b inside another fraction. This is called complex fraction. Okay, moving on to the next problem, part E. So this time we are trying to solve for z. Okay, so how about this? We multiply b on both sides first. So first of all, we multiply both sides by b. So we have x times b equals to, just like this, multiply both sides by b. So the two b's on the right side got cancelled. That is equals to ay minus z. And then this one you can, there are two ways to do it. So the first way to do it is you do xb minus ay equals to negative z, and then you divide both sides by negative 1. And then you have xb minus ay divided by negative 1. This side is a z. And then you can break this down one step further. So here is one thing that you have to know. So let's say I have 5 minus 1 over 2 that is equals to 5 over 2 minus 1 over 2. So 5 minus 1 is equals to 4, right? 4 divided by 2 is equals to 2. And then this side is a 2.5 minus 0.5. So you can see the left side and the right side got cancelled. But so the left side and the right side are equal, not cancel. But however, if you have a 2 divided by 5 minus 1, you cannot write this as 5 over 2 minus 2 over 1. This is not equal. But the above that is fine. So this, you can go one step further. So starting right here, so you can do minus x, actually is xb divided by negative 1 minus ay divided by negative 1, and then that is equals to c. And then these two minuses, they becomes a plus, so you have a minus xb plus ay equals to c. So this is how you solve for z. Another way to do it is you stopping right here. So you have xb minus ay, xb minus ay equals to negative z. This way you can swap them. So if you move the z to the other side, that z becomes a plus, right? So you have a z plus xb minus ay equals to 0. And then you move these two terms to the right, and then we change the symbol. So z is equals to minus xb plus ay. So this is another way to do it. All right, so let's do the last one, the blue one. So we have to solve for c. Okay, so let's subtract 1 over b on both sides. So 2c divided by a equals to k minus 1 over b. And then you need to multiply both sides by a. So multiply both sides by a. So this a and this a will be cancelled. And then you have 2c equals to, should I put it in or just leave it right there? You can either multiply or just leave it right there. You can multiply. Like I will just keep the a out there. K minus 1 over b, and then when you divide both sides by 2, then you have c equals to a divided by 2, and then k minus 1 over b. That's it. Alright, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. Appreciate your help and support. See you all in the next lesson. Signing out for now.